Today, we're going to take a lot of the stuff that we've been doing. We're going to find, this is another way of solving in a case where the equation isn't factorable, or maybe it is, maybe it isn't. We're giving you some ones that might have some nice answers for some of our examples, just so you can have an idea. It's called completing the square.
But first we have to understand the vocab. So standard form, just as a review, is f of x equals ax squared plus bx plus c. Then we have a little refresher from yesterday that says leading coefficient is the number in front of the squared term in a quadratic equation noted as a.
So I will tell you, this is a 7-step process for completing the square, so we can't even quite fit all the steps on here. But we're going to take you one by one through each of these steps. And I will tell you, it may seem daunting at first, but it's a process that is repeated, and it gets to be very automatic if you just practice it.
So step 1 says this: if the leading coefficient is not equal to 0, divide it out.
In our case, we have a leading coefficient of 1. So we're, it shouldn't be 0, it should be 1. I apologize, I probably should fix that. If the leading coefficient is not equal to 1, divide it out. Ours is 1, so we can move on to step 2.
Step 2 says this: set the equation equal to 0.
If it isn't already. In our case, we already have it equal to 0, so we can move on to step 3.
And step 3 says move the constant term to the other side.
So in our case, our constant term is this minus 16. To get rid of minus 16, we're going to plus 16. And so then we have x squared, and this is carrying us into step 4, so I'm going to pause for a second.
So step 4 says set up the equation in the form x to the second plus bx plus our blank equals c plus blank.
So that means we're going to have x squared plus 6x plus something equals 16 plus something. So now we move on to step 5.
Fill in both blanks with b divided by 2 and then squared, and physically square it.
Don't leave it as, in this case, you could. I want you to write down that this is going to be 6 divided by 2 squared. I want you to write that out, which in that case 6 divided by 2 is 3. 3 squared is 9. So you fill in the blanks with your plus 9 plus 9. By doing it on both sides of the equation, we're keeping the equation balanced and not actually changing the value.
And step 6 says factor the left side and then clean up the right side.
So here's the thing that's really nice. The whole point of what we say is completing the square is we are creating a trinomial over here on the left that factors into x plus or minus, in our case it's plus, something squared. And here is the cool part. That something is the b divided by 2. So this is going to be 3. And so if you actually wanted to go the long way, you could do a t-table over here. Say I want to multiply to 9, add to 6. Well, 9 is either going to be 1 times 9 or 3 times 3. 1 times 9, 1 plus 9 is 10. That doesn't work. 3 plus 3 is 6. That works. You want to have them matching each other anyways, so that's what you're looking for. That's why it's called completing the square, because 3 squared is 9. So then we clean up the other side, and we have 16 plus 9, which is 25. From there, we move on to the last piece, which is step 7.
Which is solve the remaining equation by undoing.
Now here's where some of you guys got stuck on the quiz. Make sure, the nice part is you will always be in a position where you will have your binomial squared equal to something. Whether it's a perfect square on the right side or not, it all depends on the problem we pick. So we will square root both sides. That means that x plus 3 is equal to both positive or negative 5. So now from here, we split our equation. We have x plus 3 equal to 5, and x plus 3 equal to negative 5. Got a couple of you wanting to switch the sign of the binomial. That never changes. It's the plus or minus 5. So with these, on both of them, we're going to subtract 3. And we get x equals 2 and x equals negative 8. Now before, when we solve by undoing, we let you leave it like that. Here today, now that we know solving is to find roots, I do expect you to write your answer as your x-intercepts of 2, 0 and negative 8, 0. Now, I know we've been going for almost 6 minutes already, but we got a couple other examples just so you can see some work with it. So our next one, here, coefficient, our leading coefficient is already 1. We don't need to divide it out. This has already had the constant term, our 3, moved over to the other side. So now we can start right away at step 4, where we can say x squared minus 8x plus something equals 3 plus something. So then we take our b value, which here is negative 8, and we go ahead and we take our b divided by 2 squared is negative 8 divided by 2 squared. Well, negative 8 divided by 2 is negative 4. Negative 4 is being squared, which means that it is positive 16. So we got 16, we got 16. Now when we factor the left, we need two numbers that multiply to 16, add to negative 8, which is going to be negative 4 and negative 4. So that means now we factor to x minus 4, hence this, squared. And when I clean up the right, 3 plus 16 is 19. When I square root both sides, I get x minus 4 equals plus or minus the square root of 19. 19 is prime, so we can't split it up. Here's where the nice part comes in. We don't have to split this, because when we solve and we add 4 to both sides, we end up with x being equal to 4 plus or minus the square root of 19. Now, here's where it gets a little iffy with some of you when you write your ordered pairs. That means I've got 4 plus the square root of 19, comma 0, and 4 minus the square root of 19, comma 0. And I know that looks ugly, but that's your answer. So sometimes you will have messy stuff, and that just means that if we had tried to factor that on our own, we wouldn't have been able to just straight up factor. All right, we got one more example for you. Here, we don't have a coefficient of 1, so we're going to divide it out. And if some of you are we factoring or are we dividing? We're dividing it out because we now have our beautiful equation with an equal sign. So we can divide by 2 everything. That means I'm left with x squared plus 4x. I'm going to add in my blank already, equals 12 divided by 2, which is 6 plus blank. Now when I take my b divided by 2 squared, that's 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So we put in a 4 here, we put in a 4 here. When I factor the left side, I know it's plus because my plus is here. And here is my b divided by 2, so I know that it's 2 squared, because if I did adds to 4, multiplies to 4, that's what we're going to get anyways. And when we clean up the other side, we get 6 plus 4, which is 10. Now we square root both sides, and we get x plus 2 equals plus or minus the square root of 10. Then we have to, I'm going to subtract 2 right away since square root of 10 is ugly. And we get x equals negative 2 plus or minus the square root of 10. So when we write our ordered pairs, it's negative 2 plus the square root of 10, comma 0, and negative 2 minus the square root of 10, comma 0. And that's it.
And when we divide out, we're always going to get nice numbers. We're not going to have to worry about ugly numbers when we have to divide out in this type of problem.
And he's referring to when you have that coefficient other than 1, when we divide out we will, because we're just starting to learn completing the square, we will not give you anything ugly there. If it's something that's ugly, we won't teach you this method. We'll have you do a different method, which we will learn tomorrow. So, now what you're going to do is you're going to take these two U-try problems, complete the square with them, and bring your questions with you to class.